All right, let's get into it. Today, we're going to pull back the curtain on how AI really learns. And I think you'll be surprised to find out that the whole process is a lot more human than you might think. So let's kick things off with a kind of weird question. What on earth could a student's final year project possibly have in common with a super sophisticated artificial intelligence? Well, the answer is pretty much everything. To really get this, let's start with a process that I think we can all understand pretty well. You know how this goes, right? It's that classic cycle. The student submits their first attempt, their first draft. The supervisor then looks it over, points out what's working, what's not, and sends it back with a ton of feedback. Then the student takes that feedback, revises their work, and submits a much, much better version. And this quote right here, it just nails the whole point. The supervisor's job isn't just about correcting typos or fixing grammar. It's about quality control. The real goal is to push that student to understand their topic so deeply that they are ready for any question you could throw at them. It's about building genuine mastery. So what's really fascinating is how this whole idea has a direct parallel in the world of AI. Let's see how this same framework applies to machine learning. And here we are at the most important question. A student has a human expert to guide them, but an AI, it's just code, right? It doesn't have a person sitting there marking its homework with a red pen. So how does it get that crucial feedback? How does it even know when it's wrong? And more importantly, how does it fix itself? Well, it all starts with the AI doing exactly what that student does. It produces a first draft. In the AI world, we call this draft a prediction, and the process is known as forward propagation. Now, don't let the technical name fool you. Forward propagation is really just the AI taking in some information, running it through its own internal logic, and then spitting out its best guess. It's like the AI is saying, okay, based on everything I know so far, here's what I think the answer is. That's its first draft. Let's make this super concrete with a simple example. Imagine an AI that has one job: to answer the question, should you wear a jacket today? To figure this out, it looks at 3 little pieces of data: the temperature, the wind speed, and whether or not it's raining. Now, to make that decision, the AI gives each of those inputs a level of importance or a weight. So, for example, it might decide that rain is twice as important as temperature. It multiplies the inputs by these weights, then adds something called a bias, which is kind of like a thumb on the scale to nudge the result one way or the other. And it comes up with a final answer: a 1 for yes, or a 0 for no. And that is its first draft. But what if that first draft is totally wrong? This is where the real magic happens. This is the AI's version of getting that supervisor feedback. And this process is called backward propagation. You can think of it as the AI's self-correction mechanism. The system takes the AI's prediction, compares it to the actual correct answer, and then measures the difference. That's the error. Then it works backward to figure out what went wrong. And this right here, this is that uh-oh moment. Let's say the AI predicted 1, meaning you should definitely wear a jacket. But in reality, it was a beautiful sunny day, so the correct answer was 0. The AI made a mistake, and now it has an error to learn from. So what happens next is absolutely the most important part. The AI works backward from its mistake, and it asks, which of my internal weights was most responsible for this screw-up? Did I overvalue how windy it was? Did I undervalue the temperature? It finds the culprit, makes a tiny, tiny adjustment, and then it gets ready to try again. So all of this builds into this incredibly powerful, continuous cycle of improvement, a cycle that mirrors how we humans learn almost perfectly. Just look at this. When you put them side by side, the similarity is just undeniable. The student submits a draft. The AI makes a prediction. The supervisor gives feedback. The system calculates the error. The student revises. The AI adjusts its weights. It is the exact same iterative loop of trial, feedback, and improvement. So this is it. This is the fundamental engine of AI learning. Predict, compare, correct. Forward propagation, then backward propagation. It's a simple loop that, when you repeat it millions, even billions of times, allows an AI to go from these clumsy first drafts to outputs that feel like, well, genius. And that leaves us with one final and really critical thought. That student relies on a good supervisor to get quality feedback. The AI, on the other hand, relies completely on the quality of its training data, those correct answers it learns from. So, if the very foundation of this whole process is correcting errors based on that data, what happens when the information we feed the AI is incomplete, or biased, or just plain wrong? That technical challenge, making sure the AI's supervisor data is perfect, is really what defines the next frontier of AI.